1. So x is what we're solving for. That's what these problems are going to look like when you set y equal to 0. Luke? Good. Okay, notice where x is. Okay, x is part of that quantity that's being squared. You need to get that part alone. So the first thing you're going to do is subtract 9 to the other side. So you're going to have negative 1/2 times x plus 4 squared equals negative 9. All right, now what are we going to do? Okay, we can't distribute the square, and actually the fact that everything's all packaged, all of our x's are in this squared is a good thing, because if I can get this quantity that's squared alone, what can I do to get rid of the squaring? Square root. So that's eventually what I want to do, but I can't do it until that perfect square quantity is alone. So basically this negative 1/2 is what is stopping me from doing that. How then am I going to cancel out this negative 1/2 in order to have that perfect square factor alone? Okay, so multiply by 2. I'm actually going to multiply by negative 2, because I don't want the negative there either. Oops. Okay, so I'm going to go ahead and times everything by negative 2. Really? Okay, so negative 2 times negative 1/2 will equal 1. The negative 2 doesn't also distribute here. Remember, if you're multiplying 3 numbers together, 2, 3, and 5, you don't do 2 times 3 and 2 times 5. Okay, you use the 2 one time in the multiplication. So these will then just leave a 1, which will just leave us with x plus 4 squared. And 9 times 2 will give us 18. So now I got the perfect square part alone, and I want to do what we talked about before. I want to square root both sides. What are some important things that I have to remember when I am solving an equation by using square roots on both sides? Luke? Okay, yeah, so the square and the square root are inverse operations. So on this side, it basically leaves us with x plus 4. Another couple of things to remember. If you put the square root on both sides, think about this real simply. If you had x squared equals 9, like we were playing a game or something, I'm thinking of a number when you square it, you get 9. What is my number? 3? Maybe not. Maybe it's negative 3. So when you go to figure out and get rid of a square and you use the square root to get rid of it, you have to include both the positive and negative square root values, because once it was squared, it all looked positive, and you don't know if they had started with a positive or a negative number. So this part will just be x plus 4. On this side, I need to include my plus and my minus. We're going to do this without a calculator. So that means when we have radicals like this, we want to write them in simplest form as much as we can simplify, and then just stop there, and that's it. So when I say as much as you can simplify, that means you're looking at 18 and you're thinking about breaking it down into its factors. So 18 breaks down to be 9 times 2. 9 is a perfect square. Okay? So what's the square root of 9? 3. That means a 3 will be outside the radical. But 2 is not a perfect square, so it will remain inside the radical, but it can't be broken down any further, so that's as much as I can do. Okay? And on this side, I still have x plus 4. The x is almost solved for, but it's not completely alone. Okay? So in order to finish solving for x, I would have to subtract 4 from both sides. Since I'm having you guys do it without a calculator and by hand, you're not going to know what negative 4 plus 3 rad 2 is, because you don't have a decimal value of 3 rad 2. So you're just going to have to write this as negative 4 plus or minus 3 rad 2. And those are your x-intercepts, or your solutions to this equation. Okay? How many solutions is that? 2. Okay? And are these real solutions? Yes, they are real numbers. Okay, they're not rational, but they are real. Okay, what would have made this problem have solutions that weren't real? What? Good, if there was a negative underneath the radical. Could I have still finished solving it and wrote something? Yeah, but what would my answer have included if maybe this wasn't a negative at the beginning, if the 1/2 was positive, so the 18 ended up being negative? All the work would have looked the same, but what's the one additional thing I would have here if this 18 had been negative underneath the radical? I, okay, that there would be an I out there with the 3, okay? And so that could totally happen. That means the parabola just isn't crossing the x-axis at real numbers. But that means the parabola is still there on the graph. But because it's not crossing the x-axis at real numbers, you end up with x-intercepts with I in them, okay? All right, so since we're talking about quadratics, these other two problems review other ways to solve quadratics. What if somebody didn't give it to you in this format? Now, I know tonight's are going to be in this format. But as far as college entrance exams, what colleges expect you to know and what you're going to have to use in the future of this course, not everything's going to be written in this perfect square format. Okay, quadratics could look like this. So what are the other methods you can use to solve quadratics when you can't use the square root because not everything's together in the perfect square? So like in number 2 and number 3, they have an x squared, but they also have an x in the equation. So we can't take the square root because of the x that's in there and stuff like that. Okay, so quadratic formula is a method. What else? Completing the square and factoring, okay, which some of you might factor using that bottoms-up method, okay? So you all have different factoring techniques. We'll talk about one if you struggle with that. We already did a factoring review worksheet for this purpose so that when we got here, we had a way to solve them, okay? So to check if things are factorable, you guys can use that x. If you use the bottoms up, it's part of it. Okay. Basically, if it's factorable, then the a times the c, meaning the first times the last, the 6 times the negative 5. So in this problem, negative 30. And then the b value, negative 7. If it's factorable, there are two numbers that will multiply to make negative 30 and add to make negative 7. Okay. So are there two numbers that multiply to make negative 30 and add to make negative 7? 10 and negative 10 and 3. Perfect. So once I figure out that those two numbers, it tells me two things. One is that it's factorable. And the second thing is if I then use grouping, I have the numbers that I want to use to group. Remember what we said about those numbers? We said for us, they would take the place of the negative 7x. So I would use negative 10x, positive 3x, and negative 5. And then I would go ahead and I would group. So I would look at 6x squared and 10x. What is their greatest common factor? 2x. And that would leave 3x minus 5. And then I look at 3x and minus 5. What's their greatest common factor? Just 1, because there's nothing else I can factor out of them. So I'm going to write plus 1. And that leaves 3x minus 5. So remember, you have two things here, this big thing and this big thing. And luckily, they both have something in common. What do they both have? 3x minus 5. So I take out the 3x minus 5. And then I write what each of the things were that were multiplying the 3x minus 5. In the first term, I had 2x. And in the second term, I had plus 1. So I have factored. And now to use my factors to solve, I take each one and set it equal to 0. And those are just small little linear equations that you guys can add and then divide to solve. So if you don't have a problem in this format, or if you do have it in this format and you decide to multiply it all out and get it in this format, we could use this. All right, so the next problem, 3x squared plus 11x plus 14. If I want to see if it's factorable, I need two numbers that will add to 11 and that will multiply to whatever 3 times 14 is. And 3 times 14 is 42. So are there two numbers that will multiply to make 42 and add to make 11? 7 times 6. So 7 times 6 multiplies to make 42, but when you add them together, you get 13. So we have 1 and 42 isn't going to work. 2 and 21 isn't going to work. 3 and 14. 3 and 14 would work if we're able to subtract them. Are we allowed to have one be a negative and one be a positive? No, because it's not going to work with the numbers. Okay. 4 doesn't go into it, and then we have 6 and 7. So it didn't work. So when you can't factor, you have to rely on completing the square or quadratic formula. Personally, with a 3 and an 11 there, I don't really want to complete the square. So I'll go ahead and do the quadratic formula. So those of you that have forgotten the quadratic formula, okay, a reminder, depending on what your motivation is. 1, you're going to have to solve problems in this class. 2, you're going to take some college entry-level math test, whether you go to junior college, a state school, a private school, an out-of-state school to determine your math level. And they expect you to know this stuff. So we're trying to incorporate review as we go so that you're not stumped when you go to look at those things. So if you forgot the quadratic formula, try to remember it now. All right, so negative b, which is our negative 11, plus or minus the square root. And underneath the square root, we put the b value being squared minus 4 times the a value times the c value. And we put that all over 2 times a. Okay. All right, so I have negative 11 plus or minus. There's going to be some number in the radical. And in the denominator, I have 6. All right, so my number in the radical. Cheat a little bit. So I already know 3 times 14 is 42. So then I just need to know what 42 times 4 is. Okay, so it's 168. So I basically, in my radical, I have 121 minus 168. So when I subtract those two things, I'm going to get a negative 47. So that's what's underneath my radical. So is that okay? I did 4 times 3 times 14, and I got 168. I knew 11 squared was 121, so then I subtracted them and got negative 47. Is this okay? All right, so if they asked me for real solutions, I would be done at this point. If they only wanted real numbers, I'm done because the negative's underneath the radical. Okay, however, reminder that we know now this whole complex number system that has some parts of imaginary numbers in there as well. So we can simplify this. Does 47 break down at all? No, doesn't have any factors, okay? So that means that's kind of good for you because with a calculator, without a calculator, that means less work. You don't have to do anything to break down 47 like we had to do in the last problem. So everything gets to stay the same. The only thing I have to note is I have to note this correctly, which for us, the correct way to note that would be to put the I outside the radical. And then these would be our solutions. A small way for you to check your work, if you have the graph, which you do because you did homework 6 last night, right? So you graphed all of these equations. And then tonight, you're going ahead and solving for your x and y intercepts. Your x and y intercepts, you should see those points on the graph. So your algebra work should kind of match your graph. If you get imaginary stuff, your graph shouldn't cross the x-axis. If you're getting real numbers, your graph should cross the x-axis at those points. Okay? And for your y-intercept, it should cross the y-axis at those points. Any questions about quadratic stuff? No? So just a reminder of all of our different methods. We can take square roots, we can factor, we can use quadratic formula. Sean?
When you originally put the quadratic formula together, where did you get 4?
It's part of the formula. So underneath the radical, you do b squared minus 4 times a times c. It's always 4. Yeah. So it's just part of what you have to memorize as part of the formula. Is that all right? All right. So what do all of these problems have in common? Okay. So some are square roots. What about number 6? That's a cube root, right? And our variable x is underneath all of the radicals. So in order to solve these problems, we're going to have to get the radical part alone, and then we're going to have to get x out from underneath the radical. How are you going to do that part? So like once you get to a part where you have the radical alone, but x is underneath it, and then you have it equal to some number, what are you going to do? Luke? Good, square it, okay? Because just like before, when we had a squared, we did a square root because they undid each other. Same type of idea here. Okay? So first one, I need to get the radical alone. How am I going to do that? What's the first step? Ramsel? Good. So we'll add 5 to both sides. Okay, radical is almost alone. What should I do now? Not divide by 3 yet because it's inside. Not square it yet. Coletta. Divide by 2. You could square it right now, but sometimes that gets you into trouble because of the value of this right here. So you really want to try to work to get your radical alone first. Not yet, because it's underneath the radical. So until it's outside of the radical, we can't do anything with those other numbers that were outside. So first we take care of everything outside the radical, we get the radical alone. Once the radical is alone, we want the radical gone. So like Luke said earlier, we are going to go ahead and do what undoes the radical, which is squaring. And we have to do it to both sides. Okay? So this is going to create 3x minus 5. And this is going to be 25 over 4. Now we just have a linear equation. These were equations we were solving in the first unit when we were finding x and y intercepts, and we plugged a 0 in for something and we solved. And the issue that we didn't like here is that sometimes we had fractions show up. So you guys can either solve it with the fraction here and do a lot of fraction arithmetic, or you can choose at this point to multiply everything by 4 so that you don't see a fraction again until the very end. What would you guys prefer? Multiply by 4. All right, so I'll go ahead and multiply everything by 4. So again, I don't have to do this. I'm doing this because I see a 4 in the denominator that I don't want to deal with. So then this is going to be like having a 12x minus a 20 equals, and then when this 4 multiplies here, the 4s will cancel, so I'll have 25. Okay? So it's just going to make my arithmetic easier, and if a fraction shows up, it won't show up again until the end. So now I'll add 20 to both sides. So I get 12x equals 45, and then I'll divide both sides by 12, and see, now you can see where our fraction is going to show up. So I get 45 over 12. I can reduce that. These are both divisible by 3. Okay. And so then that's going to give me x is equal to 15 over 4. Is this okay? If I wanted to make sure I was right, what if I felt like I made an error, or maybe there was something incorrect about my problem? What would I do? Mikey? Yeah, plug 15 over 4 back into the original equation where x is and figure that out. Now, I have to give you guys one fair warning. For these ones where you square both sides, make a note about checking, okay? And here's why. If you guys have, good job. Okay. If you guys have a square root, let's say we have these two problems off to the side. Square root of x equals negative 4 and square root of x equals 4. I would solve both of these problems the same way, right? I would square both sides, and I would get x equals 16. And over here, I would get x equals 16. Is 16 the answer to both of these problems? Plug it back in and check. Is the square root of 16 equal to negative 4? No. Okay. Is the square root of 16 equal to positive 4? Yes. So here's my warning. Anytime you get to a step where you have a radical and it's equal to a negative number, if you keep going and you square, you're going to get an answer. But guess what? If someone calculates this radical, would they ever say it's negative without a negative sign in front of it? No. So will this radical ever equal a negative number on the other side? No. So if you ever get to here, you can stop. Okay? Because at that point, there's no solution. So one of two things. You either have to remember this, or you have to check all of your answers in case you just keep going every time to make sure they actually work. Is that all right? Do we understand why that has to happen? Okay. If someone calculates this radical, it's not going to be equal to a negative without a negative sign in front of it. Okay. So if you have a radical all by itself, and on the other side of your equation you have a negative, that ain't going to happen. Okay. All right. Next problem. How would I solve it? What would I do first? What's up? Okay, good. Subtract 4 from both sides. Again, we see what the radical is in the radical. We want to work to get that package alone. So if we subtract 4 from both sides, we get this. Now, we don't stop right now because there's a negative on this side because the radical's not alone yet. Only if the radical gets alone and is equal to a negative, then I know I'm going to make some solutions that don't actually work. Okay? What should I do next? Yeah, either divide by negative 1/2 or multiply by negative 2, like we did in the very first problem, because negative 2 times negative 1/2 will just make 1, and you'll just have your radical left on this side. And on the other side, you'll get 8. Is this problem okay to continue solving? Yes. Okay? Because it's not equal to a negative. It looked like it might be for a minute, but then it didn't work out that way. So then I'm going to go ahead and get rid of my radical by squaring. Okay? So I'm going to have 2x minus 3 equals 64. And then I'll just finish the problem how I normally would. So I'm going to get that x is equal to 67 over 2. Okay. So are we okay when there's a square root in the problem? And we got to watch out for those ones, right? That one situation. Yeah, I think so, when there's a fraction. All right, number 6. What's the difference between number 6 and number 4 and 5? Cube root. Okay, so what's going to be the difference in my procedure for solving it? Yeah, I can't square something and expect the radical to disappear if it's a cube root. I'm going to have to cube it. So the idea is going to be exactly the same, but I'm going to be cubing stuff to get rid of the radical instead of squaring it. So first thing we're going to do is subtract 8. Now, a little bit of information. If you get the cube root by itself and it's equal to a negative, is that okay? Yes. Okay, it's only not okay with even radicals like square root, fourth root, sixth root. They're never going to equal a negative. Okay? And then here I'm going to divide both sides by negative 2 to get the radical completely alone. And then like you guys said, the difference here is that instead of squaring, we would be cubing. So we're going to have 3x minus 5 equals 64. And then we would keep solving like normal. So we would get that x is equal to 23. So the reason that we're doing these, you guys, again, I know your homework tonight is only on quadratics because we've only graphed quadratics. But the next thing that we're doing is we're going to graph a cubic. So you're going to have to solve things with cubes. We're going to graph square roots and cube roots. So you're going to have to solve things that have them in there. So I just wanted to make sure, instead of just saying, oh, you have all these Algebra 2 skills, go solve them, that you got a little reminder to make sure you did them right. So we just need to do one more to make sure we cover it. We've covered our quadratics, our square roots, and our cube roots. The only other one we have to be aware of is the cubic, meaning if you have something that's cubed. Okay? So we're going to be graphing equations that look like this. So where the 0 is, there would be a y. And if we plugged 0 in for y, it would be like we're finding the x-intercept when we're solving this equation. What are we going to do in this equation in order to solve it? So the x's are all inside of the package that's being cubed. So first we need to get that package alone because it contains all of the x's. Okay? So we'll subtract 54. Good. And we'll divide by negative 2. So we'll have this cubed package equal to 27. 27 is a really nice number. If it wasn't equal to something like 27, we would deal. And just like with our square roots, we would just kind of leave it. All right, so when it was a perfect square, we square rooted both sides. Now again, if this was a perfect square and there was a negative, we square rooted and we had to put like I and all that stuff. Do we have to include I when we're doing something like cube roots? No, negative numbers have cube roots, right? So all the odd powers are good. Positives, negatives, everything's good. It's the even powers like the squaring and the square root. So we're going to go ahead and take a cube root here because cubing and cube rooting undo each other. So we'll just get 3x minus 6. Because cube roots and cubing can be both positive and negative, we don't have to include the plus or minus. If you took the cube root of 8, it would be positive 2. If you took the cube root of negative 8, it would be negative 2. It would always have a specific sign already with it. Okay? So again, you only need to include the plus or minus with the square roots. So you have to kind of separate the idea of when it's a cube root and a square root, because they have some different circumstances and act a little bit differently. So the cube root of 27 is 3. If it didn't break down perfectly, you would break it down however you could, and it's okay to leave something with a cube root or a square root in your answer like we did with the quadratics. Okay? And then we would just keep solving like before. To get our x value. Yeah. Huh? Yeah. Because, so like, you know how I said before, no one's going to calculate a square root of something and tell you it's equal to a negative number unless you had already had a negative sign outside of the radical. But a cube root of something could be equal to positive or negative depending on what's under here. So if it was the cube root of 8, that's equal to 2. But if it was the cube root of negative 8, it's equal to negative 2 because negative 2 times negative 2 times negative 2. Yeah, works out to 8. Yeah, so it's kind of nice. Like in these ones, you don't have to worry, basically. If it's cubing or cube rooting, just go through the process and you're good. It's with the squares and the square roots that you got to like think about eyes or if this really works and stuff like that. Sierra? Not yeah. The index of the radical. Yeah, like cube roots, fifth roots, all of those ones. Yes, absolutely. So we're only going to do cubes and squares. So for us, cubes are going to be good all the time. So if we're solving a cubic or a cube root, we're just going to go and we're going to be good because of the way those plus and minuses work. But if we're solving a quadratic or a square root, we're going to have to like have our brain really turned on about if that's actually going to work and stuff like that. Okay. Any other questions about solving? No? Okay, so I know that this is a lot more than what you need. Homework